this is the function we're going to be working with in this partial project. And the first point asks us what's the domain and the restriction, and we can see that since it's a polynomial function, there is no restriction, therefore its domain is all real numbers. Next, we are asked to find the x and y intercepts, and to find the x-intercept we have to make the y equals 0, and when we clear all that we get that there's two intercepts, one at 0, 0 and the other one at 3, 0. Then for the y-intercept we make the x equals 0 and we get that it intercepts at 0, 0.
So the point is, it's asked the symmetry, and if I take the original function and I have substitute the minus x, we have this result, and these are not even. So if I substitute the negative at the beginning of the function, we have this result, and this result is equal to this result, and this odd function. So in the point D, we have to get vertical asymptotes and gaps, and we have a polynomial function, so therefore no restriction on the domain, and doesn't have a gaps or vertical asymptotes.
Okay, in the point E, we have to get the horizontal asymptotes, and to do this we have to apply the limits to infinity in our function. So when we apply the limits at infinity, we know our function doesn't have horizontal asymptotes. In the point F, we have to get the first derivative of our function. So we have to do this. This is our first derivative.
They asked us to do the ID test, and to do this we need to use the first derivative and the values of x. We can see that the values of x are 0 and 2, and that gives us the critical points at these coordinates, 0, 0 and 2, 0. This is a t-chart of our first derivative, and we can see that we graph the critical points, but we also need to find the behavior of the graph to the left and to the right of the critical points. So we use these values, -1, 1, and 3, and we plug them into the first equation. And we see that given the sign that it gives us, it either increases or decreases. And we find the behavior of the graph, and the behavior in these intervals are that from -infinity to 0 it's increasing, from 0 to 2 it's decreasing, and from 2 to infinity it's increasing.
So in the letter H, it asks that the second derivative. So here we have the original function. These are the first derivative, and these are the second derivative.
For the next point, we are asked to do the concavity test, and for this we need the second derivative of the problem. And when we make it equal to 0, we get that x equals 1. And in order to get the other point, we need to plug this into the original equation, and we get that y equals -2. And with these two numbers, we can get the inflection point, which is 1, -2.
This is our t-shirt of the second derivative. We have to get the values greater than 1, lower than 1. And we have to substitute these values in the second derivative, and if the sign is minus or positive, the concave bit change. If the sign is minus, the concave bit is going to go downward, and positive, the upward. The intervals -infinity to 1 and 1 to infinity.
Jay asked the range and the graph. So this is the the graph of the function, and this the range, and it's the all the real numbers because it goes the minus infinity to infinity.